Hello guys, and welcome back. Today's video is about lesson 1.2, and we're going to learn a little bit more about transformations, specifically how they relate or how they work with linear and absolute value functions. Okay? So one of the most basic type of transformation is called the translation. And a translation is either a shift up, down, left, or right. So we're going to take a look at the horizontal translations. And those are going to be the ones that are left and right. And then we're also going to look at the vertical translations. And those will be up and down. Okay, so we've got horizontal over here, vertical over there. Let's take a look at horizontal first. And we're going to use a quadratic function. Actually, even though it says linear and absolute value, we're going to use a quadratic. That's the one it has in your textbook. Remember, absolute value and quadratic, very, very similar. Absolute value being the V-shaped function and quadratic being the U-shaped function, but very, very similar. So let's go ahead and take a look at this. The parent function of the quadratic is f of x equals x squared. And the transformed function is going to be g of x, and it is going to be x minus 1 squared. Okay? So I'm going to graph both of these. I'm going to graph the parent first, and then I'm going to graph the transformed function, and then we're going to figure out what in fact was the transformation, or in this case, what was the translation? Was it to the left or was it to the right? Okay? So in order to do this, I'm going to do a table of values. I'm going to do a table of values for f of x, and then I'm going to do a table of values for g of x. And again, I'm going to pick my favorite numbers, and you should know them by now. -2, -1, 0, 1, and 2. And I'll pick the same numbers over here. -2, -1, 0, 1, and 2. And let's see what happens. So in the parent, if I put -2 for my x values, this will be -2, the entire number, -2, complete with the negative, squared. That's going to give me 4. And then if I do -1 squared, that's going to give me 1. 0 squared is 0, 1 squared is 1, and 2 squared is 4. Now, let's take a look at the transform function. If I put a -2 in here, that's going to be -2 minus 1, and that is equal to -3. And then we square the -3, that's going to give me a 9. So this one is 9. Let's put in a -1 here. That would be -1 minus 1 squared. And that is -2 squared, and that'll be +4. So this one is 4. We put in a 0 for x. That would be 0 minus 1 squared. That's going to be -1 squared. That is 1. Put in a 1 for x. Sorry about that. That'll be 1 minus 1 squared. That's 0 squared, which is 0. And put in a 2. So 2 minus 1 squared. That's going to be 1 squared, which is 1. Okay? So again, I'm going to graph this one, which is the parent, and this one, which is the transformed, and see what happened. We're going to do them both on the same graph just so we can clearly see what's going on. Let's make this a little bit bigger. All right, so the parent, we have -1, -2, 1, 2, 3, 4. We have -1, 1. We have 0, 0, 1, 1, and 2, 4. All right, and this you should memorize because it is the basic quadratic function, right? The parent function. Now we're going to do the transformed. It's -2, -1, -2, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's -1, 4, 1, 2, 3, 4. It's 0, 1. And it's 1, 0. And it's 2, 1. All right? So we can see this is doing this. And we could do one more point if we wanted to. If we did, for example, 3, if we plugged in a 3 here, we would get 3 minus 1, which is 2. 2 squared is 4. So that would be 1, 2, 3, 1, 2, 3, 4. Oop, a little bit higher there. So more like that. All right, ignore this. Sorry about that. But you get an idea of what happened. Now, let's take a look at the vertex here. The vertex here is at 0, 0. And the vertex here is at 1, 0. So basically what we did is we shifted the function 1 unit right. Okay? And that is in fact what happened. And when you have a transformation or a translation, this particular type of transformation, that happens inside the function, it's inside the parentheses, and you see a -1, your instinct is to think that that is going left, but it is in fact not going left, it is going right. So please remember that whenever you see inside, again, inside the function, a minus, you are actually shifting to the right that number of units. If you saw a plus, you would be shifting to the left that same number of units. Okay? So let me just rewrite this here. This dark, like burgundy, is f of x equals x squared. That's our parent. And the blue one is g of x equals x minus 1 squared, which is the parent shifted 1 unit right. Okay? So that was a horizontal one. Let's take a look at a vertical one. Again, going to use the same function here, the same quadratic function. But in this case, we're going to do this. Now I want you to look at the difference. This -1 is taking place inside the parentheses. It's what we call inside the actual function. This -1 is taking place outside the function. Here's the function. This is outside the function. When this happens, something very different happens than here. All right? So again, we're going to do 2 tables. One for f of x. And again, I'm going to pick my favorite numbers. Or actually, you know what? I'm just going to pick 3 numbers. -1, 0, and 1. Let's make it easy peasy. And then I'm going to also pick 3 numbers for g of x, the same ones, and plug them in. If I plug in a -1 here, -1 squared, that's just +1. If I plug in a 0, that's just 0. If I plug in a 1, that's just 1. Now over here, if I plug in a -1, I'm going to get -1 squared, which is 1, and 1 minus 1 is 0. If I plug in a 0, 0 squared, that's 0 minus 1, -1. And if I plug in a 1, I get 1 squared, which is 1, minus 1, which is again 0. So let's go ahead and graph these 2 guys together. Okay, so my f of x is at negative 1, 1, 0, 0, and 1, 1. And again, we know the shape pretty much. By now, we should know it. And the new function, or the transform function, is at negative 1, 0, 0, negative 1, and 1, 0. Okay, so once again, this is f of x equals x. That's my parent. This is g of x equals x squared minus 1. That is my transform function. And we can see what happened. And don't pay attention to how wide this is. This is just error on my behalf. Just look at the points. If you take a look at the points, each point was shifted down 1. Okay? And that's what I want you to get from here. So when we have a minus sign outside the function, you're going to be shifting down that number of units. So it is shifted the function 1 unit down. If it would have been a plus 1, it would have shifted this function 1 unit up. Okay? All right, so knowing this, let's go down just a little bit down here. What would h of x equals x plus 7 squared do to the function? What is that transformation when there's a plus 7 inside the function? Well, if you answered that it will shift, this is will shift function 7 units left, and you got it right. If it's inside the function and you see a plus sign, it is moving to the left. Well, what about if we had h of x equals x squared plus 7, where the plus 7 is outside the function? If you answered, it will shift the function 7 units up. You are correct. All right? So these are our horizontal and our vertical translations. Let's take a look at some examples. Now you know exactly what's going on as far as which way the function is shifted depending on where the translation is, whether it's inside the function, like over here, or outside the function. So let's take a look at some examples from your book. All right, example 1, again, it goes directly with example 1 in your book. Is let f of x equal 2x plus 1. And we want to write a function and we want to call it g, whose graph is a translation three units down of the graph of f. All right, so again, if we're saying 3 units down, that means it is a vertical translation. So we can write that here. And vertical translations occur outside of the function. All right? So let's try and write g of x. This is our f, by the way. It is not a parent function. This has already got something going on here. It's not, the parent function would be f of x equals x. This is not the parent linear function, but this is the function that we're starting with. And we want to take this function and write a function, call it g, that is this function moved 3 units down. All right? So that means that g of x is going to be whatever f of x is minus 3. All right? G of x is the function of x minus 3, because remember, vertical translations occur outside the function. So it's going to be outside of here. All right, so now what you're going to do is you're going to see that f of x is this. We're going to substitute the value of f of x for f of x. So g of x equals f of x, which is 2x plus 1, and then minus 3. All I did was substitute 2x plus 1 for f of x. And now we're going to solve this, or simplify this. This is going to be 2x minus 2. And that is your g of x that has this, that does this to this function. This g of x is this function shifted 3 units down. Okay? Let's take a look at another one. This one we're going to call example 1a. Again, these are directly related to the examples in your book. So this is example 1b. Write a function. In this case, we want the function's name to be h, whose graph is a translation 2 units left from the graph of f. Now f is going to be the same f we had up here. So I'm going to let f of x, I'm just copying it. It's the exact same function we had up there. But in this case, we want to move it 2 units left. So that's not vertical. That is going to be, this one is a horizontal translation. Okay? And horizontal translations take place inside the function. All right? So let's take a look at this. So I want an h of x that equals, we want it to be 2 units left. So I'm going to look at f of x, and I'm going to write this as f of, remember, x plus 2 takes it to the left. When it's inside the function, when it's horizontal, it's an x plus 2. So my h of x is equal to f of x plus 2. So you are replacing. Now we're going to take, replacing x, we're going to simplify this. We're going to replace x with x plus 2. So here we're going to go back to the function f of x, and wherever there is an x, which is right here, instead of writing x, we're going to write x plus 2. So h of x equals, you have the 2 from the original function, and then you have the x, but instead of x, we're going to put x plus 2, and then your plus 1. So I just copied f of x again, but wherever there was an x, I'm going to put an x plus 2. And then now we're going to simplify. So h of x equals 2x. This is just the distributive property. So h of x equals 2x plus 5. So this function here is f of x, this function up here, shifted 2 units to the left. Okay? All right. Let's take a look at some of these and see if you can figure these out. Do a little practice here. So now we have, for number 1, we have f of x equals 3x, and I want you to write a function that is a translation 5 units up of this guy. All right? So that means g of x equals f of x, right? The original, plus 5. So that means g of x, whatever f of x is, which is just 3x, plus 5. So this guy is this guy shifted 5 units up. All right, let's take a look at number 2. F of x equals absolute value of x minus 3. And I want you to write a function that is a translation 4 units right of this guy. All right? So now right occurs inside the function. So that means g of x equals f of, if it's 4 units to the right, I'm going to actually do x minus 4. Okay? And now what I do is I go back up here and I go to f of x, but wherever there's an x, I'm going to put an x minus 4. So this becomes absolute value. Instead of x, it'll be x minus 4. And don't forget your minus 3. All right, moving on. Let's take a look at number 3. F of x equals 4x minus 9. And I want a translation 5 units up. Now up and down, remember, is vertical, and that takes place outside the function. So my g of x is just f of x plus 5. All right, I'm going to substitute what f of x is over here. So g of x is just 4x minus 9 plus 5, and then simplify 4x minus 4. Okay, let's take a look at number 4. F of x is 4x minus 9 again, but here I want a translation 1 unit to the right. Now if it's to the right, that means it is horizontal translation, which takes place inside the function. So I want a g of x that equals f of x minus 1, because when you do it inside the function and it's going right, you do a minus sign. All right? And what this means is take x minus 1 and plug it in to x for f of x. So my g of x equals f of x minus 1. So I go up here, and wherever there's an x, put an x minus 1. So that's 4 times x minus 1 minus 9. And then I have to simplify that using distributive. This is 4x minus 4 minus 9. And g of x equals 4x minus 13. Okay? All right, now we're going to take a quick look at reflections. when they occur over the x-axis and when they occur over the y-axis. So, reflections on the x-axis, look like this. Y equals negative f of x. There is a minus sign in front of the function. So when you see a minus sign in front of the function, it's a reflection on the x-axis. So this is a reflection of y equals f of x over or on the x-axis. All right? When you see it like this, this would be reflections on the y-axis. Your minus sign is inside the function. Okay? So here the minus sign is on the outside. That's a reflection on the x-axis. When you see a minus inside the function, it'll be a reflection over the y-axis. This is reflection of y equals f of x over the y-axis. Okay? Let's take a look at example 2. Again, this is example 2 from your book. And that's Charlie in the background barking at who knows what. I don't know if you can hear him. Charlie is a really large Belgian Malinois. And he's very sweet, but he's very loud. Alright, so let f of x equal absolute value of x plus 3 plus 1. So this is our given thing. And part A, we want to write a function, and we want to call it g, whose graph is a reflection. So immediately in our minds we should be thinking, okay, there's a minus sign involved. We just need to figure out whether it's inside or outside. Is a reflection in the x-axis. So that answers that. It's going to be on the outside of the graph of f, which is this guy. All right, easy enough. So my function g of x is just going to be negative f of x, the minus in front of the f of x. And to simplify this, we put the minus, and then this is very important. In parentheses, we put the entirety of this f of x function. So it's the absolute value of x plus 3 plus 1. Okay? This is g of x. And now we're going to distribute that negative sign. So this gets distributed here and here. You put a minus. You keep that absolute value thing going. Negative 1 times positive 1, that's also negative 1. So this guy is this function up here reflected on the x-axis. Now let's do with the same f of x, let's reflect it on the y-axis. So we're going to write a function h whose graph, and that is not Charlie, by the way, that is my husband making noise back there. Telling me I need to wrap up pretty soon. So you can thank him when you see him. Write a function h whose graph is a reflection in the y-axis of the graph of f. All right, so again, this is f of x. I'm just going to copy it down because we can't see it. But in this case, I want to reflect it in the y-axis. So my negative sign will have to go inside the function. So if I write that, that would be it's h. We want h of x equals f of negative x. All right, we want the negative sign inside the function. So now what you do here is where you go back up to f of x, and wherever there is an x, you're going to put a negative sign. So h of x equals, we copy the absolute value sign. Instead of x, we're going to put negative x plus 3, close the absolute value, plus 1. All right? Let me scoot this up just a tad. Sorry about that. Now, at this point, a lot of people like to stop, but I don't want you to stop. I want you to pull out, and this is going to be the same story all the time. I want you to pull out a negative 1 from here. So if I pull out a negative 1, this will become x minus 3. I just factored out a negative 1. That's all I did. And the reason I did that is because now I can simplify this to h of x equals, now the absolute value of a negative 1 times x minus 3 is equal to the absolute value of a negative 1 times the absolute value of an x minus 3. You can break it up, which is really nice, because we're going to simplify this guy very quickly, and then you have a plus 1. Now, what is the absolute value of a negative 1? And this is why it's so nice. It just becomes a 1, and then you're left with x minus 3 plus 1. And even to simplify it further, 1 times the absolute value of x minus 3 is just the absolute value of x minus 3 plus 1. So this is one that you're going to be using a lot when we do reflections on the x-axis. I'm going to want you to pull out the negative 1 and make it a 1. And then that will change what's on this side. So you'll see that the change happens. Then the plus 3 becomes a negative 3. But this is much easier to look at and to read than this right here. Okay, so we do want it in this format. All right, let's do a quick self-assessment. So let's see how we're doing. Oops. Let's take a look. And these are all about reflections over the x or the y-axis. So I want you to just kind of assess yourself and see, do I know what I'm doing here? Do I understand this? All right, so number 1, you have f of x equals negative absolute value of x plus 2 minus 1, and you want a reflection on the x-axis. All right, so if it's on the x-axis, that means the minus sign needs to go in the front of the function. So my g of x is negative f of x. All right, this minus sign goes straight down. Now we're going to write f of x. Again, you must use parentheses and write the entire function in there. So this is negative absolute value of x plus 2 minus 1. And now you're going to distribute this negative 1. So negative 1 times negative 1, that's going to be positive x absolute value of x plus 2. And then negative 1 times negative 1, that's going to be plus 1. So make sure you do that. Make sure you distribute that negative 1 with the entire function. All right, now we're going to look at this one. Here, f of x equals 1/2 x plus 1, and you want a reflection in the, or on the, not really sure which one I should use, on the y-axis. All right, and if you remember, reflections on the y-axis happen inside the function, so that means g of x is going to be f of negative x. And that means that wherever there is an x in f of x, we are going to put a negative x. So this is 1/2 times negative x plus 1, and that's just negative 1/2 x plus 1. Okay, so hopefully that wasn't too bad. We're going to move on to horizontal stretches and shrinks next. Horizontal stretches and shrinks. Okay, so either a stretch, a shrink, or a compression. So we're going to let f of x equal absolute value of x minus 3 minus 5. And we want a horizontal shrink by a factor of 1/3. Now, horizontal shrinks are like horizontal translations. They occur inside the function. So this occurs inside the function. And instead of using the factor that they give you, we use the reciprocal. So the reciprocal of 1/3 is 3. So not only is it inside the function, but we use the reciprocal of the factor. All right, so let's see what all of that means. So I want, let's call the function g of x, I want the function to be a horizontal shrink by a factor of 1/3. So that is going to happen inside the function, but instead of 1/3 being multiplied by x, I'm going to multiply it by its reciprocal, which is 3x. So g of x equals f of 3x. When it occurs inside the function like this, it is being shrunk, even though it's a 3 is bigger than 1/3, but it is being shrunk by a factor of 1/3, even though you see a 3. I know, it's counterintuitive, kind of like when we did addition and subtraction inside the function, it was the opposite of what we saw. Well, here it's very similar. If it's being multiplied by a 3, it's actually being shrunk by a factor of 1/3. All right? And so now what this means is we go back to our f of x function, and wherever there's an x, you're going to put a 3x. So g of x equals, we're going to copy this, absolute value, instead of x, we're going to put 3x minus 3, absolute value minus 5. And that is that. Okay? So it's a little different. Now we're going to do a horizontal stretch. By a factor of 5. So once again, this is going to be g of x. If it's a stretch by a factor of 5, this is actually going to be f of 1/5 x. Okay? Again, it looks like it would be shrinking because it's a fraction, but this is really a horizontal stretch by a factor of 5. So wherever there is an x in the original, let me tell you what f of x is. F of x equals absolute value of x minus 1 plus 2. So we're going to look at this guy. Wherever there's an x, we're going to put a 1/5 x. So g of x equals absolute value. Instead of x, we're going to put 1/5 x minus 1 plus 2. Alright, these are probably the trickiest ones to do. Horizontal stretches and shrinks, and horizontal translations. Left and right are the tricky ones because it's the opposite of what you think it should be. Alright, let's take a quick look at vertical stretches and shrinks, which are actually really easy because they are what you think they are. So if we want a vertical stretch, and vertical stretches are going to occur, and shrinks are going to occur outside the function. And you use the actual factor, so you keep the factor they give you. And I'll show you what I mean by that. Vertical stretch by a factor of 2 for f of x, and we're going to let f of x equal absolute value of x minus 3 minus 5. So my function, and again I'm going to call it g, you can call it whatever you want, g of x is going to be a vertical stretch by a factor of 2 of this guy. So it's just 2 times f of x. So really simple. And we're going to put a negative 2, I'm sorry, not a negative 2, a 2, and then we're going to multiply it by whatever f of x is. Well, f of x is this whole thing. So we need to put that in here. Okay? But you are not done yet. You need to simplify by distributing that 2. So we're going to distribute the 2 here and here. And that's going to give me 2 absolute value of x minus 3 minus 10. Alright? You may need to watch this video more than once. I'm warning you right now until you get the hang of it. Because there's a lot. There's a lot to unpack. And that's kind of the way it is at the beginning of the year. Alright? There's just a lot of stuff about functions we need to learn very, very quickly, unfortunately. Alright. Part B, a vertical shrink by a factor of 0.25. Now again, vertical stretches and shrinks occur outside the function, and we keep the factor that we see there. So let's say that f of x, this is the original, let f of x equal absolute value of x minus 1 plus 2, and we want to shrink it by a factor of 0.25. So that's going to be g of x equals 0.25 times f of x. Alright? And that means we're going to do g of x equals 0.25. Please put your brackets or parentheses or some sort of grouping symbol to put the entire function in there, because then you're going to have to distribute. And now you're going to distribute with this one and that. So g of x equals 0.25 times the absolute value of x minus 1, and then 0.25 times 2 is 1/2, or 0.5. Alright. Almost there, guys. Almost there. Okay, example 4, describing a transformation. Alright, so if they give you a table, here we have x, here we have f of x, and if x is negative 3 f of x gives me 10. If x is negative 2, f of x gives me 6. If x is negative 1, f of x gives me 2. And if x is 0, f of x gives me 6. All right, so that's the relationship there. And then I give you another table that is called g of x. And g of x is 5, 3, 1, and 3. And they ask you, what is the transformation of g of x from f of x? You need to look and see here. All right, so my x's are not changing. X is negative 3 here, and I get a 10. Down here in g of x, x is still negative 3, but now I get a 5. Up here, when x is negative 2, the function produces 6. But over here, when x is negative 2, the function produces 3. Here, when x is negative 1, the function produces a value of 2. But here, when x is negative 1, it produces a value of 1. Here, when x is 0, the function gives you a value of 6. But here, when x is 0, the function gives you a value of 3. So you can see that going from here to here, you are taking 1/2 of the number, right? 5 is a half of 10. 3 is 1/2 of 6. 1 is 1/2 of 2. And 3 is 1/2 of 6, right? We could just, if we just multiplied each of these by 1/2, 10 times 1/2 is 5, 6 times 1/2 is 3, 2 times 1/2 is 1, 6 times 1/2 is 3. So now it becomes clearer. This graph, g of x is the one I'm talking about. The graph is going to be, is a vertical, because it's happening outside, shrink, sorry about that, shrink by a factor of 1/2. Remember, it happens outside. It happens to the final result here. You just multiply it by 1/2. Okay? And example number 5. Let's let f of x equal absolute value of x plus 2, and let's let g of x be negative f of x minus 1. Can you describe the transformation? Actually, a question. Can you describe the transformation? If this is what I wrote for g of x, what is the transformation or transformations that are going on? Well, I immediately see two things going on. I see a minus sign here, and I see a minus 1 over here. So the minus sign in front is a reflection on the x-axis. And a minus 1 inside the function is a shift 1 unit right. All right? So you should be able to do those types pretty straightforward. All right, and we reached the last problem. Yay! All right, example 6. Let the graph of g be a vertical shrink by a factor, by a factor of 0.25 followed by a translation 3 units up on the graph f of x equals x. All right. So let's see what this means. Vertical shrink happens outside. So vertical is outside. And vertical also is what it is. So we are actually going to use that factor. So it's outside and a 0.25 factor. All right. So let's call this function g of x, shall we? So g of x is going to be 0.25 multiplied by f of x. So that's the first part. Now the next part is followed by a translation 3 units up. So units up occur on the outside, so this is just really easy, plus 3. All right, and then all we do here is where there is an f of x, you're going to put the x, and so this is just 0.25x plus 3. And you are done. All right, guys. Well, thanks for for putting up with this very, very long lecture, but there really is a lot in the first few lessons in this book. I promise they do get shorter as the year goes on, but at the beginning, a lot is thrown at you. So please don't give up. Please watch the video several times. Please ask questions in class. You're going to be okay. Trust me. It's just a lot at first. All right, well, I'll let you guys go and see you on the next video. Bye.